The attacks started after dark. Munitions hit Iran's southern coast for a few hours, and by morning, someone was counting what was left. The same thing happened the next night at the same hour, along the same shoreline, and then the night after. 13 nights in a row, and across all 13, the sky over Iran sent nothing back. War is meant to go both ways. One side hits, the other hits back, and the exchange breaks somewhere. This one ran with the response loop missing. So where did the S-300s go? Tehran paraded those launchers through the capital for years, a long-range Russian system meant to make Iranian airspace expensive to enter. Feeding them are long-wavelength radars sold on the promise of detecting aircraft other systems cannot see. Most of that network is gone after 5 months of war. But that only moves the question somewhere more interesting, because not one American pilot had to fly within range of those launchers to take them apart. The attacker never touched the wall. Every weapon in this story is a circle with a number attached to it. How far it reaches, and no further. Navy intel runs those numbers. Stay to the end, and you will be able to run them yourself on any air defense system. Start with the number Tehran was proudest of. Start with the constraints Iran was actually building around. Decades of arms embargo, no access to a modern fighter production line, a fleet too old and too thin to fight for the sky. Under those conditions, the options narrow to one. If you cannot own the airspace, deny it from the ground. Spread out batteries, mobile launchers, stacked by altitude band. The design follows from the inputs. The strongest layer was the S-300 Russia delivered in 2016. Its engagement envelope runs to about 105 nautical miles. Its acquisition radar reaches further, giving around 160 nautical miles of warning before anything enters missile range. Keep that first figure. Everything else in this story gets measured against it. The simple explanation, that the defenses were somewhere else, falls apart on the map. Bandar Abbas is Iran's main Gulf naval base and has hosted long-range air defense for years. Qeshm Island at the mouth of the strait had batteries and early warning radars at full readiness through the spring. The Bavar 373, Iran's homegrown long-range system, was designed specifically for this stretch of water. The coast was not unguarded. So, the question is harder. The missiles were right there, and none of them fired. Why? The answer is not in the hardware. It is in an assumption that governed air warfare for a century, and quietly stopped being true. Air defense worked because of one underlying rule. To bomb a target, you had to fly over it. Every attack path crossed the defender's circle, and that crossing was the whole point of ground-based air defense. Desert Storm was still fought that way. Tomahawks and F-117s opened the door over Baghdad, but the F-117 had to go inside to do it, with stealth as the only thing keeping it alive. 35 years later, the same job gets done without anyone going inside. What is actually running this campaign is a specification, not an air force. The engagement radius is a hard outer limit built into every weapon ever made, past which it stops working. Iran has one, and so does the United States, though its limit is measured in something other than distance. The circle stayed put. What changed is where the shooter chose to stand. Start with the one standing farthest back. The B-1B Lancer is not stealthy. It is large, hot, and easy to pick up on radar, so sending it into defended Iranian airspace would be throwing it away. If any part of that network was still up, why was the B-1B not being knocked down? Because it never appeared. The AGM-158B, JASSM-ER it carries, reaches past 500 nautical miles. The S-300 below reaches 105. At 500 miles, the bomber sits outside every sensor pointed at it, so the screens stay empty. The defended envelope never enters the problem. Where the aircraft lives follows from that ratio. Once the release point is 500 miles offshore, the runway can be anywhere within fuel range, which is how these bombers operate out of RAF Fairford in England and fly the full distance. B-52Hs run the same profile from the same base with the same missiles, so the B-1B is not unique here. It is just the most extreme case, and the extreme is where the physics reads most cleanly. The figure that actually matters is not payload. It is how much ordnance reaches targets per exposure of the aircraft. 3 bomb bays, 3 rotary launchers, 24 JSMs internally, 75,000 pounds, the heaviest load in the Air Force. 4 aircraft can put about 96 stealth cruise missiles onto a coastline from several directions at once, and the number of times any of those airframes entered a threat envelope to do it is 0. The risk variable the defender was counting on has been removed from the equation. The weapon has its own survival problem and solves it differently, by going low rather than staying far. JASSM pays for that with speed. Subsonic, slower than anything ballistic, a long time in the air. What compensates is altitude, or the absence of it. Radar horizon is a formula, roughly 1.23 times the square root of the height in feet, added for both radar and target. A coastal radar 30 feet up first detects a cruise missile at 100 feet from about 19 nautical miles out. That same radar sees an aircraft at 30,000 feet from about 220 nautical miles, more than a 10-to-1 difference, decided entirely by how high the target flies. So that 105-mile envelope was always for high-altitude targets. Against a missile running low, it shrinks to 19 miles. At subsonic speed that is under 2 minutes to identify the contact, assign a battery, and get an interceptor out. The defender runs out of seconds long before running out of interceptors. The bomber gives up stealth and agility. The missile gives up speed. Both purchase the same thing: distance from the threat. What neither can buy is a shot at anything that moves. Coordinates loaded before takeoff only work on something still there after a flight halfway around the world. A launcher that relocates at dusk, a boat that is a valid target for 20 minutes. Those are a different problem, and the answer does not fly out of England. The F/A-18E Left Super Hornet has been called the workhorse of the air campaign over Iran, and the description fits. 13 consecutive nights. Targets hit and hit again as they shifted position. That is a carrier air wing's tempo. 2 strike groups have been on station through July, built around USS Abraham Lincoln and USS George H.W. Bush, with the Boxer amphibious group alongside. But look at the Super Hornet's numbers, and something seems contradictory. Combat radius roughly 390 nautical miles. JASSM-ER reaches about 160. Joy multiplies glide bomb around 70, all far short of what the bomber carries. The Super Hornet does not get to stand 500 miles back. So how does it survive night after night at much closer range against a network that had been degraded but was still shooting? It does not extend the weapon. It moves the starting line. A ground base has to be built where geography and politics allow, which in this theater means far enough back to be safe, placing the target past a fighter's reach. The carrier solves that by moving the runway to the Gulf of Oman. From a rear airfield, 390 nautical miles does not reach the Iranian coast. From a flight deck parked offshore, it does, every night. Think of 2 archers. One has the longer bow, the other walks closer. Only here the one walking closer brings the floor with him, and that floor displaces 100,000 long tons. The obvious objection is that Iran has anti-ship missiles on that coast, so why is the carrier allowed to sit there? Because hitting a ship at that distance is a targeting problem before it is a missile problem. A launcher can only fire at something someone has located, and the same horizon math that hides a cruise missile also hides a warship. A shore radar cannot see past the curve of the Earth to a hull hundreds of miles out. Getting there requires a surveillance chain, over-the-horizon radar, maritime patrol aircraft, satellites, drones, each passing along a track precise enough to shoot at. Every link either radiates or flies, which makes every link a target. That chain is what was being taken apart night after night. The result shows up in what the aircraft carries. Footage from the campaign shows an F-2020E off Abraham Lincoln carrying an AGM-84K JASSM-ER, a standoff cruise missile sent against coastal targets from outside the range of most of what Iran had left. Release and turn away. Never a run at a defended point. This is where Iran's air defense was actually being consumed. Suppression work means chasing mobile launchers and coastal radars that appear and vanish. That is a job for something that can be overhead minutes after a target appears, not something 8 hours out of England. The bomber takes out what was already identified. The carrier air wing takes out what just revealed itself. The same precision shows up at the campaign's smallest scale. When a tanker ran the blockade and ignored warnings, an American aircraft put a hellfire into its smokestack, wrecking the exhaust trunking and the machinery below, leaving the ship dead in the water with the hull intact and no oil spilled. The point was to stop it moving, and the weapon was chosen to do that and nothing more. Both aircraft stay outside the engagement envelope by opposite methods. One outranges it, the other relocates the starting line. Which brings us to what Iran was counting on to break the arrangement, the part viewers ask about most. Go through the target list from those 13 nights and one category keeps repeating: air defense systems, coastal radar sites, command centers, communications nodes, then air defenses again. One night saw roughly 90 targets struck. Same category, same locations, hit again. That looks like waste. It is the opposite. It is an investment calculation. Launchers, boat sheds, port facilities all cost the same to service on night 13 as on night 1. Air defense is the only target where removing it today reduces what tomorrow costs. Take out one engagement radar and the release point for the next sortie moves closer in. Shorter range weapons become viable. Targets previously out of reach come inside the envelope. Spend the early nights reducing the price of the later ones. The network was not being fought. It was being depreciated layer by layer in a fixed sequence because each layer does a different job. An integrated air defense runs a chain: acquisition, track, fire control, intercept. Different radars, different frequency bands. That chain has to complete for a missile to leave the rail. An attacker only needs to break the weakest link. Iran's chain had a gap built in from the start. Search radars reach about 160 nautical miles. Interceptors reach 105. Every system ever fielded has this gap, because a radar return is cheap, and a missile with fuel is not. On paper, that is 55 nautical miles, but 105 assumes a high-flying target, and nothing was flying high. Apply the horizon math, and a cruise missile only becomes engageable in the last 20 nautical miles of its approach, while the search radar still picks it up at 160. The zone Iran could watch but not engage was closer to 140 nautical miles. Fire control sits at the inner edge of that gap and gets stripped first, by design. Getting a firing solution means illuminating the target, and that turns the emitter into a beacon. An AGM-88 flies down the beam to the source. Shutting down on launch warning does not help much, because the AGM-88G JASSM-ER carries satellite-aided inertial navigation and a millimeter wave terminal seeker, meaning it can still find an emitter that has already gone dark. Emission control stopped being a survival option when that seeker entered service. The engagement layer degrades. The search layer survives. The surviving half is the half that cannot shoot. The long wavelength radars fit exactly here, and the Iranian claims about them hold up technically. VHF band sets operate at wavelengths measured in meters, while low observable shaping is designed against the short end of the spectrum. Push the wavelength toward an airframe's structural dimensions, and resonant scattering returns a signal where an X-band set finds almost nothing. These radars genuinely detect what fire control radars miss, and they survive the campaign because they never put out a targeting beam for a seeker to home on. But check what they contribute. That same wavelength means wide beam width, coarse angular resolution, long pulses, low repetition rate. Bearing accuracy too poor for a firing solution. VHF extends detection range and adds nothing to engagement range. It widens the gap it was bought to close. By the end of the campaign, that gap had only grown. Engagement capability removed one battery at a time, search capability left standing, and the most advertised part of the architecture extending the very distance that was defeating it. That is a network being dismantled rather than beaten, and it explains the pace. There was no decisive single night on offer because this was a depreciation schedule. That schedule leaves a mark on the map. Late in the campaign, strikes were reaching hundreds of miles inland from where it opened on the coast. Nobody had to announce the defended zone had shrunk. The target list moved, which says the same thing. The logic reached its endpoint in something that stayed on the water. Corsair unmanned surface vessels, 24-foot hulls carrying 1,000 pounds over 1,000 nautical miles, entered a naval base and struck a submarine sitting on a crane. Remove the pilot, remove the aircraft, and what remains is a hull nobody minds losing. The only thing going inside the threat envelope is the thing that can be sacrificed. This makes the campaign a preview as much as a conclusion. If the winning move is to shoot from outside reach and send something disposable inside, what happens when both sides can do it? The answer was shown this summer, not over Iran. Off the Marianas, a B-2 launched an AGM-158C at a decommissioned amphibious ship and sank it, the first confirmed anti-ship use for that aircraft. The C variant is the maritime version of the same JASSM family flying over Iran. Same missile lineage, same standoff logic, aimed at ships rather than radar installations. It is being adapted to the Pacific, where targets make 30 knots and shoot back. A position outside everyone's reach is not free, though. In 2026, American forces fired about 1,100 JASSMs and took delivery of 484. 2.5 going out for everyone coming in. The same ratio that opened the door is now running the other way. Global stocks of the extended range variant dropped from around 2,300 to near 425. Most of the worldwide inventory was committed to one theater, and getting back to pre-war levels will take years. Range is also measured in how many nights you can keep firing. Geometry sets one limit and it does not move. Manufacturing rate sets the other, and it shrinks every night it is used. That boundary does not appear on any map. It lives inside a production line. There is a quieter cost still. An intact penetrator warhead was recovered from a missile that came down without detonating. Composite airframe in pieces, 1,000-pound core and fuse intact, the fuse being the part that counts material layers as it drives through them to time a detonation inside a buried target. It was at least the third such recovery, which makes it a loss rate rather than bad luck. Fire thousands of rounds and a percentage comes back to be studied. The attrition goes both directions, just at different speeds. One side loses launchers. The other loses stockpile and the exclusivity of its own engineering. Go back to those 13 nights arriving at the same hour over the same coastline, with nothing ever coming back. Iran's defenses were watching the whole time. They were just stuck in an exchange they could not answer. Being denied a turn every night is what dismantling looks like when it is done from a distance. What happened over Iran was not a shield being broken. It was a shield converted into a target and ground down from a range it was never built to handle. That approach is not confined to one theater. The same math is being aimed at open water, where targets make 30 knots and shoot back. What you are left with is the math, and it works on any system. Take the advertised engagement range. Subtract what the horizon takes away against a low-flying target. Compare what remains against the reach of the weapon aimed at it. The number that comes out of that is the only one that was ever real. 500 nautical miles against 105. Whoever holds the larger number sets the terms, and the side with the smaller one never gets a turn.